Good morning friends. We are starting with differentiation today. This is the first step into the world of calculus. Calculus नाम सुनते ही कुछ लोगों को डर लग जाता है. But believe me, there is nothing to worry about. We'll start from the very basics. If you have taken math at +2 level, it will be a good revision for you. And if you didn't do it at +2, आपने अगर 11th-12th में maths नहीं भी लिया था, even then you will find it interesting and easy to grasp if you follow along the lecture series. Differentiation and integration have tremendous use in economics. So our intent will be to not only learn the ropes of the topic but also to get to its economic applications. हम calculus or for that matter any other topic of quant करेंगे for the purpose of using them in economics. In differentiation, we will cover the following topics. Introduction to simple differentiation. Here we will get introduced to differentiation with a very practical and visual example. Next, we will cover the rules of differentiation with lots of example questions and exercises for you to grasp them fully. We will use the rules of differentiation and add on those of logs in differentiation of logarithmic functions, which will be our third topic. Once we have well understood the concept of derivatives, we will move on to second order and higher order derivatives. Lastly, we will apply our knowledge of derivatives to economics in economic applications of simple differentiation. सबसे पहले, very briefly, we will understand what is differentiation. This lecture I have divided into two parts. Part 1 is a visual example to introduce the concepts of differentiation. Part 2 is the actual mathematical interpretation of this example. चलो फिर start करते हैं. Let's say you are traveling in a car. आप point A से point B travel करते हो in a certain time period. At the end of your journey, if I ask you how fast did you travel, you will give me one number. You will see कि आपने कितना distance travel किया, कितने time में किया, and using these two values, you will find out your trip's average speed as total distance traveled divided by total time taken. ये formula तो हमारे दिमाग में बैठा हुआ है. Speed is equal to distance upon time. We have been using this formula since ages. But if I ask you how fast were you moving at exactly say 9:30 am or 10:41 am, you would not be able to tell, because what I am asking you right now is the speed at a particular instant. What you can tell me using the information you have is the average speed. It smoothens out the effect of the entire trip into one value as if it were a uniform motion. It ignores the traffic, the intermediate stops, acceleration, deceleration, etc. आप अपनी जर्नी के दौरान कहीं रुके भी होगे, कहीं ट्रैफिक होगा तो गाड़ी धीरे चली होगी, कहीं खाली सड़क होगी तो तेज़ चली होगी. एवरेज स्पीड हमें इसमें से किसी की जानकारी नहीं देती. As I have said, it just smoothens out the effect of the entire trip into one value, as if it were a uniform motion. Life doesn't happen in averages. It happens in instants. ट्रैफिक पुलिस वाला आपका चलान एवरेज स्पीड के बेसिस पर नहीं काटता, बल्कि उस इंस्टेंट में आपकी गाड़ी की क्या स्पीड है जो कार का ओडोमीटर उस इंस्टेंट में रीडिंग दिखा रहा है उसके बेसिस पर काटता है ना. दिस इज वेयर कैलकुलस कम्स इन. लेट्स अंडरस्टैंड डिफरेंशिएशन यूजिंग दिस सिंपल एग्जांपल ऑफ एवरेज वर्सेस इंस्टेंटेनियस स्पीड. फर्स्ट, लेट अस प्लॉट डिस्टेंस एंड टाइम ऑन अ ग्राफ. हियर वी ड्रॉ x and y axes. टाइम इज ऑन एक्स एक्सिस. टाइम को आवर्स में ले लेते हैं. डिस्टेंस इन माइल्स इज ऑन वाई एक्सिस. लेट्स जस्ट से पॉइंट ए इज एट अ मार्कर ऑफ 50 miles initially, that is from the origin. He starts at a point A and then moves at varying speeds to finally reach at point B, which is at a marker of 200 miles, as you can see here. So this curve is not a straight line because the speed we are saying is not constant but varying. कहीं पे स्पीड कम थी, कहीं पे स्पीड ज़्यादा थी, कहीं पे गाड़ी रुकी हुई थी. So his speed was not constant. His average speed can be calculated as distance traveled, that is between points A and B, upon time taken in reaching point B from point A. Clear है यहाँ तक? Distance between points A and B is 200 minus 50 is equal to 150 miles, and time taken between these 2 points is 3 minus 1 is equal to 2 hours. So, his average speed is 150 divided by 2 is equal to 75 miles per hour, which if you see is the slope of this line that connects these 2 points. Slope of this line is this length in blue, which on the y axis shows the distance travelled upon this length in red, which on the x axis is the time taken. And this line whose slope we have calculated as the average speed is called the secant line, Now, the secant line connects 2 points on a curve, as we can see here. But if we want to find instantaneous speed, that is speed at a particular instant, let us say the speed at just a nanoth second close to b, we need to find the slope of a line which touches the curve at that one particular point. We need to find the slope of a line which touches the curve at that one particular point. Let us take point A closer to point B, keeping point B fixed, so that the distance between the 2 points reduces so very much that the line connecting the points A and B literally becomes a tangent to the curve. Do you see here that as point A goes closer to B, the secant line starts getting shorter and shorter, moving upwards as if rotating anti-clockwise here. And when A is so close to B that we cannot even see the distance between the two with naked eye, the line connecting them now becomes a tangent. Slope of this tangent now will give us the instantaneous speed at that particular point A, which is just a fraction of a second behind B. This instantaneous rate of change of a function with respect to an independent variable is calculated using differentiation. It is called instantaneous because it is happening at that very instant where the tangent is touching the curve. You may ask, why bring the points A and B so close to each other so that the time interval between them becomes minuscule? Why not merge the 2 points to get the tangent? Well, that is exactly the intent. If you see the equation here, average speed is equal to change in distance divided by change in time. Change in time cannot be 0 for the mathematical equation to hold. You cannot have 0 in the denominator as a divisor. आप 0 से तो divide नहीं कर सकते ना, इसलिए we take the time interval as approaching 0 and not exactly 0. In differentiation, to get the instantaneous rate of change, we apply the limits as approaching 0 and not exactly 0. Let's see mathematically now. Distance is a function of time, as we have just seen here. If we denote distance with y here and time with x, we can simply write y is a function of x as y is equal to fx. Let's name this equation as equation number 1. Here x, that is time, is an independent variable, and y, which is distance, is a dependent variable dependent on time. So, distance is dependent on time. Here we use a term called increment denoted by a triangle, which is read as delta, which means a small change or increment in value. So, a small change in the value of x is delta x and a small change in the value of y is delta y. Let the coordinates of point A be x and y. At x time, y distance has been travelled. So, the coordinates of this point A are x, y. Then of point B are x plus delta x, y plus delta y. Using the original equation 1, this one, if y is equal to fx at point xy, ये point xy है हमारा, है ना? एक बार फिर से y is equal to fx क्या डिनोट करता है? That distance y is a function of time x. Distance y is a function of time x. So, y plus delta y becomes f of x plus delta x. Let's name this equation as number 2. Remember, delta x and delta y क्या है? Change in value of x from here. That is the time interval from A till point B, and delta y is the change in distance from point A till point B. Now subtracting equation 1 from equation 2. So on LHS, on left hand side, we get y plus delta y minus y, and on the right hand side we get f of x plus delta x minus f of x. Y and y cancel out, we are left with delta y on the left hand side. It is equal to f of x plus delta x minus f of x. Mark this equation as 3. Now we know that average speed is equal to change in distance upon change in time. So divide both sides by delta x and we get average speed is equal to delta y by delta x. Delta x is the change in time. So that is why we have divided both the sides with delta x. So we get average speed is equal to delta y by delta x is equal to f of x plus delta x minus f of x divided by delta x. ये हमारी एवरेज स्पीड आ गई जो हमने पार्ट 1 में एग्जाम्पल से देखी थी. देखो, व्हाट वाज आवर डेल्टा वाई, दैट इज चेंज इन डिस्टेंस 200 minus 50 if you recall, right, 150 miles. What was delta x, that is the change in time, it was 3 hours minus 1 is equal to 2 hours. So our delta y by delta x was 75 miles per hour. Delta y by delta x is called the average rate of change of y with respect to x. Delta y by delta x is called the average rate of change of y with respect to x. Now we saw in the example, as point A moved closer and closer to point B, the time interval got smaller and smaller. That is, delta x, which is the time interval of her journey from A to B, starts approaching 0. As delta x approaches 0, we denote this as delta x with an arrow like this, approaches 0. The secant line becomes a tangent. So the instantaneous rate of change is defined as the limiting value of average rate of change. Very important, this definition. The instantaneous rate of change is defined as the limiting value of average rate of change. Average rate of change हमारे पास क्या था? Delta y by delta x. Now delta y by delta x is change in distance over change in time, right? So instantaneous speed is simply the limiting value of average speed. This limiting value has a special name, dy by dx. It is read as derivative of distance with respect to time. Y is the distance, so d by dx of y, derivative of distance with respect to time. From equation 1, if we write fx in place of y here, equation 1 में क्या था? Y is equal to fx, so y को if we substitute with fx, we get d by dx of fx, which can also be written as f dash x. It is also called as f prime x. These are all the ways in which we can denote a derivative, dy by dx or f dash x. We will sometimes also call it as f prime x. So derivative can either be written as dy by dx or f dash x. So what did we learn today? If y is a function of x, then change in y with respect to x, that is delta y by delta x, gives us average rate of change. And when delta x approaches 0, then the average rate of change approaches the instantaneous rate of change. This limiting process is known as differentiation. In the next lecture, we will introduce the very basic rules of differentiation. So stay tuned. Thank you.